I loved science in high school. It was, a lot of classes were easy to me in high school, and then science was easy to me then, but it was also just interesting. So then I want to keep like asking questions to figure more things out. And so I was like, okay, I know like this is where I really want to study. Falling down, getting back up. Because college for freshman year for me was really rough, having to adjust to not succeeding exactly how I expected. And so I feel like me having determination and just knowing like it's okay to not do well at first, I just kind of had to learn like you'll get there and you'll make it in your own time. Everybody has their own process. Everybody has their own story of like how they get there. So that was best for me. During the week, I have I'll write out my schedule, then I'll set out a certain time where I'll go like meet with a tutor, or I'll go to the library and study for a certain amount of time. If I need to have a nap, I have to schedule like a certain time. And then on the weekends, the way I try to schedule is in the mornings, me and my roommates, we have a time of everybody has to be in the living room at 10 o'clock. And so we study till about 2 or 3 o'clock, and then after 3, that's it. We'll go and maybe go to the gym or then go have fun, just to keep our mental health good just as well as our physical health, just everything kind of in balance, because at first I was just studying and that was it. And then it's like, okay, you're getting crazy and now you're getting emotional. You're on this emotional roller coaster and it's like you're crying for no reason, or then you're working on problems and you don't understand. But if you don't allow yourself that break or that balance, then everything could kind of just become comorbid. Being determined, being persistent, continuing just to try harder, having that time management, having social support. I feel like you need social support to continue to help you. You need to be able to be open-minded. Don't be so, no, this is exactly what I want to do. You have to be a little flexible, kind of learn and kind of go with the flow, and eventually, what's made for you will come to pass. Hi, my name is Raven Williams, and I'm an undergrad here at Birmingham Southern College. And today I will be discussing with you about pH. Now, pH is used to specify whether an aqueous solution is considered acidic or basic. And we usually use a scale ranging from 0 to 14. And we kind of use these numbers to help us specify whether it's neutral, acidic, or basic. If it's a 7, then it's considered neutral. If you have below a 7, if you receive a pH of below 7, it's considered acidic. And if you have pH above 7, it's considered basic. Now, before we dive further into this video, I would like to inform you all that pH is used in everyday life. It's not just used for chemistry majors or biology majors or physics majors. If we talk about digestion, we have hydrochloric acid within the stomach, and when we digest our food, this acid is breaking it down. However, if the acid gets to a level beyond our limitations, then our stomach begins to get irritated or we receive some type of pain. We also have acid in the mouth. It can be formed when we eat sugary foods and it connects with the bacteria that's already in the mouth, and then that will cause damage to our enamel, our teeth. So just be mindful that pH is used in everyday life. It is not just for particular majors. It is useful because the improper balance of pH can mess with our health. So now that you have that little background, there's also a formula that we use to help calculate pH. pH equals the negative log of hydronium ion concentration. Now, you also have the pOH, and to get pOH, it will equal 14 minus pH. So I've given you some formulas. However, I have not given you anything to put these formulas to use. So what we will do, we will work a strong acid problem and a strong base problem. First, we will work a strong acid problem. I'm back as promised with a strong acid problem. So the question states, find the pH of a 0.0018 molar solution of nitric acid. So the formula, let's go ahead and put the formula up, which is the formula for finding the pH. It's the negative log of the hydronium ion concentration. I would use an ice chart. An ice chart has the initial concentration, the change, and the equilibrium. Well, we have to have a formula to go through this ice chart. We'll start off with nitric acid, just mixing with water to yield the hydronium ion concentration plus the nitrate ion. All right, well, we already know initially we do not have to worry about water due to the state that it's in. Now, the initial concentration of the nitric acid was 0.0018 molars. We have nothing of these two concentrations initially. We know that the change is then 0.18, and they are gaining this molar solution. Now, if we look back at our formula, we see that we need the concentration of the hydronium ion, which is what we have here. This is what we have right here. That is what we need for this formula. So we can plug it in. Everybody get your calculators out. Now, I don't know if you can see this, but then you'll do the negative and the log is on the other side with the other equations that you can use on your calculator. You'll do negative log of 0.0018, 2.74. Did you get that on your calculator? Now, if we want to check just to make sure, because we worked a strong acid problem, says the pH is 2.74. If we go back to our scale that we had originally in the beginning, 0, 14, and 7. 7 was neutral. If anything was below it, it was considered acidic. 2.74 fits within this range. I think we did a great job here, you guys. The next problem we will work will be a strong base. All right, you guys, I am with a strong base problem. So this question says, find the pH of 0.0067 molar solution of potassium hydroxide. So this is a strong base, as I have stated. However, it is asking for the pH, okay? So remember that pH equals the negative log of hydronium concentration. And the base, or POH, is 14 minus the pH. So we still need this concentration of the hydronium ion. So the way that we can relate this hydronium ion concentration with the hydroxide concentration is through Kw. And Kw is 1.0 times 10 to the negative 14th. Okay? So now that this is in this formula, or in this scientific notation, we're going to change this concentration to scientific notation. It'll be the same thing. So we'll move it 1, 2, 3 times. Make it 6.7 times 10 to the negative third molar, okay? So if we know that Kw is the hydronium ion times this hydroxide, and we have the Kw and we have the hydroxide concentration, then to get the hydronium concentration, we can divide Kw by hydroxide. So plug in the numbers. Kw was 1.0 times 10 to the negative 14. divided by 6.7 times 10 to the negative third. Let's put this into the calculator and let's see what it gives us. Always take your time and make sure that you put in the correct numbers, because we can easily make a mistake on our behalf and then it'll throw our problem all the way out of whack. See, I just messed up right there. I put 6.7 times 10 to the negative 7 is to the third. So start back over if you did that on my behalf, if you didn't catch it. All right, that gives us 1.5 times 10 to the negative 12. Now, the reason why I did 1.5, I know on our calculators it says 1.4925 continuous numbers is because we're using sig figs. So remember your sig figs as you go through the equations or through the problems, okay? So the concentration we got for hydronium ion was 1.5 times 10 to the negative 12. Now, what are we supposed to do next? Well, we have the concentration. We can plug it into our regular formula for pH. pH equals the negative log of 1.5 times 10 to the negative 12. Well, let's see what that gives us. 11.82. All right, so that's the pH of this potassium hydroxide solution. However, if you did want to find the pOH, this is the way you could do it. 14 minus 11.82. And that gives us 2.18 roughly. Now, do we want to check our situation out? Let's use our chart that we used earlier just to make sure that we're stating it's still basic, because we worked a basic solution or a basic problem. We got the pH was 11.82. That is above 7. That's basic. Great job, you guys. I hope this video has helped you. Come back for further services, and please remember, pH is important. Keep your balance. Thank you.